So welcome to section 1.3. This is going to give you some practice with equations where you actually have the variable on both sides of the equation. Now you know in your answer it's only going to be on one side. You're going to have an answer that says x equals something or something equals x. So you have to figure out how are we going to get the variable only on one side. That means you get rid of one. So of course you have two options here. We can either get rid of the 2x or we can get rid of the 12x. So let's think about strategies here. A lot of people like to get rid of it on the right side, so that way their answer will look like x equals a number. So let's get rid of it on the right side. We're going to subtract the 12x. Whatever you do on one side, you do on the other. So look what happens on the left side. We have 2x, we owe 12x. That means that right now we owe 10x. We still have that 5. And what do we have on the right side? We have nothing. So I'm going to put the 0 there. Now we have a two-step equation just like we did before. We need to get rid of the negative 10, we need to get rid of the 5. If you remember from before, it's easier if you undo the addition first, so we will undo it by subtracting. Wow, we got a lot of negatives here, but we know how to work with negatives. So the negative 10x comes down, that positive 5, negative 5, they're gone. And on the right side we have 0 minus 5, and that's going to give us negative 5. Last step, get rid of the negative 10. It's attached by multiplication. We're going to disconnect it by division. Right, we're going to undo the multiplication by division. Whatever you do to one side, do to the other. Look at all those negatives. Well, they're going to be gone. They're gone. Negatives cancel out, 10s cancel out, and all we have left is the x. That's exactly what we want. Negatives cancel out. We're left with 5 over 10, and fraction masters know that they can change that back into just positive 1/2. So let's double check it. Go back to the beginning. We have 2 times that half. We have the 5, and that's supposed to equal 12 times the half. 2 times the half is 1. We still have the plus 5, and on the other side we have 12 halves, which equals 6, and yay, it worked. It was true. But wow, that was a lot of work. So let's try a different strategy. Let's try getting rid of it on the left side instead of the right and see what happens. So now I'm going to get rid of that 2x instead. So subtracting 2x is the same as subtracting 2x. And what does that leave us with on the left side? Just the 5. The 2x's are gone. And if we look at the other part, that leaves us with a 10x. Okay, look at that. There's only one thing left to do. Get rid of the 10. How do we get rid of it? We're going to divide by 10. Whatever we do to one side, do the other side. And we end up with, in fact, let's make that red. We end up with 1/2 equals x. Exact same answer as we had before because, as you saw, that was the right answer. However, much cleaner process, fewer steps to do. So, why did that happen? Well, for starters, we're moving everything to where the x term will be positive. And the way you achieve that is you have to be ambidextrous, basically. You have to be able to work with the variable either on the left side or the right side. I guess that's not ambidextrous, it's ambiquationist, I guess. So we want to get rid of whichever coefficient is the smallest one. And so since 2 is smaller than 12, I got rid of that, and by getting rid of the smaller one, you end up with a positive coefficient next to the x, and that's going to make things work out much more quickly and more easily for you. In problem 2, you'll see that everything is the same as it started as problem 1 was, except I threw in a plus 15 over here on the right side. Okay. So we're still going to start out the same way we started out the last time. We are going to eliminate the smaller coefficient, or the x term with the smaller coefficient, and that's going to be the 2x. So I'm getting rid of the 2x, just like I did before. So just like in problem 1, all that's left on the left side is a 5. On the right side, we have the 10x, just like we did before, but we also have this 15. Now if you stand back and look at it, or sit back and look at it, it's going to look just like the two-step equations you were doing in section 1.2. So you'll solve those the exact same way. We look at the x term, we have to eliminate the 10 and the 15. What do we undo first? We undo the addition by subtraction, so we're going to subtract the 15, and now on the left side we have a negative 10, and on the right side we have a positive 10x and nothing else. The 15s are gone. We're now going to divide both sides by a positive 10, and what are we left with? We're left with negative 1 equals x. If you're not sure, we take it back to the top and double check it. So we're going to replace each of these x's with a negative 1. And so when we run that through on the left side, we're going to have two negative 1's, which will be negative 2. We add 5, and altogether you owe 2, you have 5. That means you have 3. If you go on the right side, you have 12 negative 1's, which gives you negative 12. And then we're going to add 15. If you owe 12 and you have 15, that also gives you 3. So yay, it worked, and that proves to us, I lost the negative there, that x will equal negative 1. So here's a problem I'd like you to try on your own first. If you look at it, it has a variable term on both sides and it has a constant term on both sides. But what I want you to be careful of is look at the left side's variable. Because if you look at this, that x has a negative 5 with it. So what I want you to think about is which side has the smaller variable, the variable term, the left side or the right side, and then get rid of that term and work it out from there. So pause the video, try it on your own, and then come back. So when you looked at the left side, you see that 5x and the right side has 2, and so yeah, 5 is bigger than 2, but that 5 is negative. So you have to ask, what's a larger number, the negative 5 or the 2? And the 2 is going to be the larger number, so we're going to actually get rid of that negative 5. How do we get rid of it? Well, we undo subtracting by adding, so we're going to add a 5x, in other words, put it back, and we're going to add 5x to the right side. So when we do that, we still have that 10 on the left side, but the variable term is gone. Now look at the right side. You have 2x and, right, because this is adding here. So, and you also have the 5x, so that gives you 7x, but you also have 3. Now you're back to a section 1.2 equation. We're going to undo the addition first, and once you do that, oh, look at that, how nice the numbers work out. What a coincidence. And that's just going to be the 7x. We then undo the multiplication by division, and we get final answers x equals 1, or 1 equals x. Plug it back in, and you'll see that on both sides, you'll end up with 5 equals 5. So this will be a good time to pause the video, stand, stretch, because I'm going to next take you through how distributive property works in an equation where you have variables on both sides. I'm actually not going to show you anything new, it's just how we're going to bring all these things together from section 1.2 and 1.3. So here you go. Variables on both sides. This is a positive x, this is negative. So we have to be careful with that. And we have variables on both sides. So here we go. Step 1, use your skills for distributing. So we have 2 groups of x, which is 2x. We have 2 groups of negative 5, which is negative 10. That's the left side. Right side, we have 4 groups of 2, which is 8. And we have 4 negative x's. So that's going to be a minus 4x. So, which side has the larger coefficient? Is it the 2 or is it the 4? And of course, the trick question, because this is a positive 2, this is a negative 4. So to keep things as simple as we can in a complicated problem, we're going to get rid of that negative 4x. So we're going to actually add 4x to both sides. So there's plus 4x and there's plus 4x. And so now when we look at this, Let's go back to black. So we had 2x, we're adding 4x, so that gives us a 6x, but we still have that minus 10. If you look at the right side, we have an 8, but no more x's. Bam, you've got a problem straight out of 1.2. 2 steps left. We need to undo the multiplying 6, we need to undo the subtracting 10, and as you remember, we're going to undo the subtracting 10 first, so we're going to add 10 to both sides, plus 10, plus 10, draw the line. You have a 6x, the 10 is gone, the right side is 18. Mental math problem at this point, divide both sides by 6, and what do you have? You have x equals 3. Go back, plug it in, double check it. Be careful with the negatives, but everything should work out fine. So here's the grand finale of this part of section 1.3. And this is actually, this section, part of the section only deals with how to do the math. When we do part 2, that's going to be how to interpret your answers, because I'm going to give you some problems that have some different types of answers. So what looks difficult about this? Well, there's a decimal there. Now, in this case, the decimal will be easier to think of as a fraction, because what fraction is 0.5? Yeah, it's 5/10, but I'd rather think of it as a nice, easy 1/2. And if you think of it as 1/2 times even numbers, everything works out evenly. What you want to be careful of as you do this problem is that the 1/2 is only distributed to the 4 and to the negative 6x, but not that plus 1, because the plus 1 is outside the parentheses. So try this out. Pause the video, try it out. Be careful, especially as you're working with the negatives, working with that plus 1 that's outside everything but is still part of the problem. And then come back to the video after you're done. Okay, so as I told you, I'm going to think of this as a 1/2. So I'm going to distribute the half times the 4, and half of 4 is 2. Half of 6x would be 3x, but a positive half times a negative 6x is going to be minus 3x. And we still have that plus 1. We're not going to forget about that. On the right side, we're going to multiply the 2 times the x. We're going to multiply the 2 times that negative 6, and so we get minus 12. So at this point, we have variables on both sides. So think about which one's going to have the smaller one. Is it going to be here, or is it going to be here? And yes, 3 is bigger than 2, but you're going to remember that that's really a negative 3. So therefore, that is going to be the small one, and that's what we're going to get rid of. And we're going to get rid of it by adding. So we're going to add the 3x to both sides. And I really encourage you to be careful and neat on how you're writing this up. You want to really keep everything lined up so that way you can keep track of the numbers. So as I do this, I still have the 2. I don't have any x's anymore on the left side, but I still have that 1. Now look at the right side. We had 2x, we have 3 more x, so altogether that's 5x, but there's also minus 12 here. Now, it actually looks a little more complicated because you still have some stuff to deal with on the left side. But that's going to be really easy to clean up, because if you go back to what your kindergarten teacher probably taught you, 2 fingers plus 1 finger, we're going to just say that that's 3 fingers. And then we have a 3 equals 5x minus 12. And again, just like before, you're doing all this math in order to bring these complicated equations all the way down to just a basic 2-step equation, which we have here. So we're going to undo the subtraction first by adding 12 to both sides, and that's going to give us 15 on the left side. It's going to give us 5x on the right side, and when we divide by the 5, we're going to be left with 3 equals x, and you can go back, plug it in, and it should work out for you. So now you can go to Edmodo, take a look at the first part of the 1.3 problems, check your answers, and then be sure to ask any questions before you go on to the next part.